Now we arrive to these formulas which we are going to use here onwards. Radius of an electron which is revolving in an nth shell, velocity of the electron and energy of electron which is present in an n shell. Now, how to calculate number of revolutions per second? It's very simple actually. Number of revolutions per second means if we consider, suppose very simple, this is a nucleus and let us consider this is a shell. So, how will you calculate that number of revolutions? Distance travelled by the electron, so that is nothing but perimeter and the velocity. So, number of revolutions per second is equal to velocity of the electron divided by 2 pi r. Velocity of the electron divided by 2 pi r. Now we know velocity, we know r, we can substitute the values. So after substituting velocity of the electron 2 pi square k z e square upon nh divided by 2 pi the values of r, that is n square h square upon 4 pi k z e raised to e square into m. Or instead of that directly put these values, but remember that this has to be converted into meters. So number of revolutions per second is equal to velocity of the electron divided by 2 pi r, meter per second divided by meter. So that meter get cancelled, hence that value becomes number per second, so that we require. So these values we are getting from these two relations. Now we know that velocity is equal to, we can take directly the value also, so we can write number of revolutions per second is equal to 2.18 into 10 raised to 6 into z by n divided by 0.529 into 10 raised to minus 10 n square by z. Okay, because we are taking this in a meter. So if we calculate this, we are getting 6.67 into 10 raised to 15 multiplied by z square upon n cube. So these are number of revolutions per second. So this is one small derivation, small relation. Sometime there may be a question based on this. So if we consider, calculate the number of revolutions of an electron revolving in a third shell for hydrogen atom, then just we have to substitute the values. So you will get number of revolutions per second. So we will take one or two problems and then we will go for the next part. So based on this relation and these relations, now we will solve few problems. The first problem, calculate the velocity of an electron placed in the third orbit of hydrogen atom. Also calculate the number of revolutions per second that this electron makes around the nucleus. So here two things we have to calculate, one is velocity and the other one is number of revolutions per second. So we can use this relation to calculate number of relation we can use this relation to calculate velocity. So, velocity is equal to, so directly I am taking this one, 2.18 into 10 raised to 6 multiplied by Z. They are talking about hydrogen atom, so Z is 1. Placed in third orbit, so N becomes 3. So that gives your velocity, and if we calculate that, it is something around 0.7 3 into 10 raised to 6 meter per second, or 7.23 into 10 raised to 5 meter per second. So that will be your velocity of the electron revolving in a third shell. Now how we will calculate number of revolutions? Number of revolutions per second. So that is a beauty of solving such kind of a problem, if we know how we are arriving to the formula, because we know this concept. So directly now we can put relation, what is that, 6.67 into 10 raised to 15 multiplied by Z, 1, so it becomes 1 square, divided by n cube, so 3 cube, 27. Solve this, you will get the value for number of revolutions per second. So if we put some extra effort initially, then it is not difficult to solve problem. Many times people are focusing only on the formula, but it is necessary, as I am consistently saying, only formula will never help you. We have to understand how are we arriving to the formula. So this is for these relations. Now there is one more problem which we have discussed the concept about ionization energy and excitation energy. So this problem is ionization energy of He plus is 19.6 into 10 raised to minus 18 joules per atom. Calculate the energy of the first stationary state of Li2 plus. First stationary state 1 and 1 is equal to 1. So first of all, we know what do you mean by ionization enthalpy. Here actually we are removing electron from outermost shell. In a helium, that outermost shell is first shell. So we are actually removing electron from first shell to infinity, and that time the energy which is given is how much? 19.6 into 10 raised to minus 18 joules per atom. So we will write for helium He plus actually what? Excitation energy. So I will write in a systematic way. Delta E is equal to E2 minus E1. E2 becomes 0 because that is for infinity, minus minus plus. So what we are writing that? 13.6. We are going in the same way, energy, right? 13.6, right? Multiplied by Z, atomic number of helium is 2, so it becomes 4 divided by first shell, so 1 square, so 1. Okay, and that is equal to how much? This is in electron volt I am talking about. Okay, so I can directly take it as 19.6 into 10 raised to minus 8 joule per atom. Rather, we can keep this thing as it is. So what I am doing here, instead of substituting, delta E is equal to certain constant, we know that a big constant we have, multiplied by constant, multiplied by what? Z square upon N1 square, and that is equal to what? 19.6 into 10 raised to minus 8 joule per atom. Okay. For Li2 plus, same concept. So here I am writing this as delta E dash. That is equal to same way constant that remains same Z square. Here I am writing Z1 square divided by N1 square because that N1 is same. That is equal to what? That we have to calculate. Let us consider that is x joule per atom. Okay, take the ratio. So x divided by 19.6 into 10 raised to minus 18, 10 raised to minus 18. Okay, so sometime we are doing such kind of silly mistakes which I have done. Now in an exam we are always come across with such kind of a mistake. So be careful, the problem is very simple. So x upon 19.6 into 10 raised to minus 19 is equal to constant multiplied by Z1 square upon N1 square divided by constant multiplied by Z square upon N1 square. So x is equal to, constant get cancelled, Z for helium is 2, so that become 4, for lithium it is 3, so that become 9. So we have this get cancelled, this get cancelled, so we have 4 by 9, 4 by 9 multiplied by 19.6 into 10 raised to minus 18. So you will get the answer joule per atom, and that value is coming 44.1 into 10 raised to minus 18 joule per atom, joule per atom. So some of the lengthy calculations we can do, but if you observe such problems, so this is what ionization enthalpy for electron when we have to remove from Li2 plus ion. Okay, now if you observe carefully the values now, 19.6 into 10 raised to minus 18 joules per atom, helium and lithium, number of shell same, only Z is changing. See, the value has almost increased thrice. Okay, so as the nuclear charge increases, ionization enthalpy also increases. Okay, this we can easily explain. So this is a kind of a problems which we will be come across while solving some IIT questions. Okay, in the next session we will be discussing about the excitation of electrons and the hydrogen spectrum.